Hi everyone, this short video has been produced to help with questions that may appear in the Scottish Qualification Authority's exam for the Higher Physics course. Once again, we are in the R-dynamic universe space and we are looking at special relativity. Now this area is one primed for use with large equations. Let's have a look at the question. A long asteroid passes overhead at a constant speed in the night sky, just as you're looking up at it. You just open the app on your phone, Aster Measure, and point it at the space rock and note its length as 175 meters. Meanwhile, on the rock, a life form called Frank already knows the length of this small world is 300 meters. What speed do you understand Frank's world to be moving at? Then we have a choice from A to E of different speeds, including D, which challenges you that you can't take the square root of a negative number. So what's our approach here? Well, we're going to read the question closely and pick out the things we're being asked about. We know that there are two people, you and the alien, that have different lengths for things, and we know we're being asked for a speed. We need to look at the options and see if there's anything obvious we can ignore. Well, in this question, it looks fairly complex, so there's nothing obvious that stands out. All the units, except for D obviously, look to be correct for a speed. Recall that this is the dynamic universe part of the course, so you can ignore all the other parts and read the question again in your head and avoid overcomplicating. Don't become terrified by the nature of the question. Just relax and take another go at it or come back to it. So this question is focused on special relativity and the time and length dilation equations. So we need to understand what information we are given and what we're being asked for. The question contains two lengths, so we're not going to be using the time dilation equation. We can focus on the length dilation equation, and we don't even need to have remembered what that is because it's given to us in the data sheet, but we do need to remember that that's what we want to use. Now we need to be sure what the question is asking for. It's asking for a speed, and so when we look at the equation, we need to know that we're going to have to do some rearranging of the equation because it's this term v that we're going to be trying to find. V is the speed here, so we need to rearrange for that, and that's probably the hardest part of this question. So let's do that rearrangement and go and find the answer. Now remember that the way you have been taught how to rearrange equations can be specific to your school and your teacher. All the methods, no matter what you've been taught, will end up at the same place, and no doubt I may have used shortcuts here, so it's important you use the method you've been taught, but we should all end up in the same place. So let's do that rearrangement. First thing we're going to do is pull the L across, so obviously we're going to divide that L, and then we're going to want to get rid of that square root on the right hand side by squaring the part on the left hand side. This already looks a bit better. Then we're going to take that number 1 across, so it's plus 1 on the right hand side, so it's minus 1 on the left hand side. And then we are just going to multiply the whole thing by negative 1, just to make it easier to work with. And then we're going to, all I've done there is simply take away the brackets on the right hand side, square the top, square the bottom, so that it's easier to move these terms around. I'm going to take the cross multiply and take that c squared across. Now we've got v squared, which is getting close, so we obviously need to take the square root of what we have on the left hand side to leave us with v to find that speed. So that's quite a complex process and easy to go wrong. Some of the things in there that might not have been obvious were obviously this part where I've decided to multiply by negative 1, and that was just to make sure we got rid of this negative here, which is particularly not useful. And then this part here where we have just multiplied out the terms so that it's easier to handle each of these terms on their own. So it might just be worthwhile practicing before the exam rearranging equations. Any old equation you find in any old book, just have a go at rearranging it and that will help. So now that we've rearranged for V, we just need to plug in the numbers. And when we do that, we find that the answer we're looking for is the bottom answer. So actually, when we plug in the numbers, noting that the c squared we can find in the data sheet, it's not supplied here, but it is available. There aren't too many numbers to plug in. We just again need to be careful how we plug these things into the calculator so that we do the correct bits first before we do arrive at the speed. So give that a go. Literally, I would suggest you give that a go with your calculator now just to make sure you agree. So that's a very tricky question. It's easy to get lost or confused by the story. So ignore the story and focus on the variables you've given. Maybe just write down the variables in the margin of your question paper to help decide which equation you need to use and decide which variable it is you need to find so that you know to rearrange the equation for that variable. And be careful when doing that rearranging. It's so easy to go wrong there. And especially in a multiple choice question where marks for working out won't be awarded. We're only going to be awarded marks for the answer, not how we got there. So that's particularly important that we watch the rearranging. Not forgetting to square numbers and take square roots is always where I fall down. I also fall down on negatives and positives, so watch for that. Don't forget to use the whole numbers in the equation. Don't do any roundings as you go. And make sure the answer is the actual dimensions you've been asked for. So just check that your units work out to be meters per second in this example. Here are some extra examples to have a try. The answers are on the Hi page, hy.page/physics, FYSX. Give those a go. And as always, thanks for watching and subscribe for more questions.